So let's take a look at this trigonometry question from the 2011 Leaving Cert Ordinary Level paper. We're given a triangle here, ABC, and told that BC has a length of 6, the angle ABC is 90 degrees, the angle CAB is theta. We've also been told that sine theta is equal to 3 over 5, which tells us the ratios of two of the sides. We're asked to find AC, so the first thing we should do is put an X on that side so that we're focused on which of the sides of the triangle we're trying to find. Because it's a right angle triangle, we can use the ratios tan, sine and cos to give us some more information about the triangle. We're told that sine theta is equal to 3 over 5. So sine is the ratio of the opposite side to the hypotenuse side, and we're told that that's in the ratio 3:5. So let's label the opposite side of the triangle and the hypotenuse of the triangle. The remaining side down the bottom, AB, is the adjacent side, but we're actually not concerned with that in this question. So we know that the ratio of the opposite side to the hypotenuse is 3:5, but we can see that the opposite side is 6. So if we let the ratio 3:5 equal 6 over x, we can cross multiply to find out what x must be. So if we cross multiply, 3 times x is 3x, 6 times 5 is 30. That means that 3x is 30. So if we divide both sides by 3, we get x equals to 10, which means that the side length of A to C is 10 centimeters. So part 2 of the question asks us to find the distance from A to B. We've already found out in part 1 that the distance from A to C is 10, so make sure we update our diagram with that information. We're trying to find A to B, so we're going to label that side Y because we've already used an X in the first part of the question. And when we have two sides of a right angle triangle and we're trying to find the remaining side, we can use Pythagoras theorem to solve this. So Pythagoras theorem is in the tables. The one thing to be careful of when you're using this formula is that the side that goes by itself in the formula on one side of the equals, that must be the hypotenuse in the question. So in our question here, that has to be the side of length 10. A and B are interchangeable. It doesn't matter if we have y squared and 6 squared or 6 squared plus y squared. They mean the same thing. So if we sub these into the formula, we have 10 squared, the hypotenuse squared, is equal to y squared plus 6 squared, the sum of the squares of the other two sides. 10 squared is 100, equals y squared plus 6 squared is 36. We're going to subtract 36 from both sides to get the y squared on its own. 100 minus 36 is 64, and then we're going to find the square root of 64. So the square root of 64 is 8 centimeters. And then just to finish the question, we'll write down the notation that they asked for. So AB, the distance from A to B, is equal to 8 centimeters. So part 3 of the question asks us to verify that cos squared theta plus sine squared theta equals 1. Now, before we do anything else, it's important just to recognize that cos squared theta is the same as saying the cos of theta squared, and that sine squared theta is the same as saying the sine of theta squared. So what we're looking to do is to use the triangle to find the ratios for cos theta and sine theta. We're going to square both those ratios. We're going to add them together and see does that equal to 1. As in part 2 of the question, we want to make sure to update our diagram before we start, so we know that the distance from A to B is 8. And we're going to use the ratios in our tables to find cos theta and sine theta. We want to label the sides, so theta is the angle CAB, and so the opposite side to theta is 6. The adjacent side, the side that's beside the angle, is 8. And the hypotenuse, the side opposite the right angle, is 10. We're interested in the cos theta first of all, so cos is equal to the adjacent side over the hypotenuse. The adjacent side is 8 and the hypotenuse is 10, and so cos theta equals 8 over 10. We can simplify that to be cos theta equals 4 over 5. The sine ratio then is the opposite side over the hypotenuse. The opposite side is 6 and the hypotenuse is 10, and so sine theta is equal to 6 over 10. This can be simplified to sine theta equals 3 over 5. So taking this equation down here, we're going to square the cos theta ratio and square the sine theta ratio. So 4/5 squared plus 3/5 squared. 4/5 squared, square the top and square the bottom, is 16 over 25. 3/5 squared, square the top and the bottom, is 9 over 25. 16 over 25 plus 9 over 25 is 25 over 25, and 25 over 25 is 1. And so we have verified that cos squared theta plus sine squared theta is equal to 1.